Hey guys, this is Miss Shank. I know some of you are still struggling with some of the combustion or choo-choo problems. I'm going to go ahead and balance two choo-choo problems for you. The first one is going to be a little more simple, and then the second one is going to require us to bump it up. Okay, so number 18 is a pretty straightforward choo-choo problem. So I'm going to make my list, carbon, hydrogen, oxygen on both sides. Why don't you try to count them now without looking at my count? Pause if you need to. So on the reactant side we have 3, 8, and 2, and on the product side we have 1, 2, and 2 plus 1 equals 3. I really do encourage you to not just write 3, but to write it out as 2 plus 1, meaning that there's 2 oxygens here on the carbon dioxide and 1 more over here in the water. Okay, do you guys remember what we said about combustions? What do we always want to leave last? Oxygen is what should have come to your head. So usually I start with carbon, then I move on to hydrogen, and I save oxygen for last. How can we fix the carbon? We'll need to multiply the product side by 3. Where will that go? It goes up here in front of the CO2. So now, not only have I changed carbon, but I have changed oxygen. That's why I encouraged you to write oxygen as 2 plus 1 equals 3. You haven't multiplied that whole 3, you've only multiplied the part that was the 2. So CO2 up here had 2 oxygens, and now I've multiplied those 2 oxygens by 3. I haven't changed the plus 1 that came from the water. So I'm going to write it down here as 2 times 3 plus 1. Now let's focus on hydrogen. To fix the hydrogen, I can multiply the product side by 4 to get 8. Where do I put the 4? I have to put it in front of the compound H2O. So now I've affected this other oxygen. Pause and really think about this. How can I fix this down here? I have 2 times the 3 and 1 times 4 because there was 1 oxygen and hydrogen, in water, and I multiply water by 4. So how many oxygens are there? 6 plus 4 equals 10. Okay, this is when we decide whether or not we need to bump it up. So 10 is an even number. On this side I have a 2, not from adding, but just from one place. Does 2 go into 10? Absolutely. 2 times 5 equals 10. Where does the 5 go? It goes in front of the O2. That's why I said this combustion is a pretty straightforward one. I don't have to do anything to bump it up or change it in any major ways. What about the other combustion? Number 19. Well, let's check it out. Let's make our choo-choo list. You should have gotten 2, 2, 2, and 1, 2, 2 plus 1 equals 3. Again, we're going to save oxygen for last. Let's start with carbon. Multiply by 2 on the product side. Put that 2 in front of CO2. I really encourage you to pause here and think about how that affects the oxygens on the product side before you look at how I put it. So the 2 times 2, and then we still have just plus 1 over here. Okay, so is that plus 1 going to change? Well, hydrogen is 2 on both sides, so I don't have to put anything in front of the water. So the plus 1 remains. So 2 times 2 from right here, plus 1 from right here, makes 5 oxygens. Now, is this a simple problem, like the last one? No, we have an even-odd problem. 2 cannot go into 5. 2 cannot go into any odd number. So this is when we need to bump it up. Again, 2 over here and 5 over here are not compatible. And I can't just do a common multiple like I might do in some other problems. The reason I can't do the common multiple is because I'm having to add to get that 5. So anytime you add, common multiples are not going to help you. Okay, so if I'm gonna bump it up, I'm just gonna start over, start fresh. Where do I bump it up? Hopefully by now you know that when you have to bump a combustion, you start all the way at the beginning with a 2. And let's mark down here where we're doing that. Okay, so the hydrogen and the carbon both get multiplied by 2. Not the oxygen though. Because of this plus sign, oxygen is separated. So only carbon and hydrogen just doubled. Okay, let's focus on the product side now. How do we get carbon? Times 4. So now we have 2 times 4, and we still have that plus 1. Is that plus 1 going to change this time? This time we do need to fix hydrogen by multiplying by 2. Put that 2 in front of the H2O. Okay guys, how will this change? You think about it. 2 times 4 plus 1 times 2. So how many oxygens is that now? 8 plus 2 equals 10. Now this is solvable. How will we finish it up? Make 10 oxygens on the other side by multiplying by 5. Where does the 5 go? Right there in front of the O2. And now we have a fully balanced chemical equation.